Assalamualaikum warahmatullahi wabarakatuh. We have learned chapter 2.5 elementary matrix. Now is tutorials time. Tutorial time. So let's we discuss exercise from book exercise 2.5. Question 1. You should ready with exercise 2.5. So turn to page 84, exercise 2.5. Question number 1, determine whether the matrix is elementary. Alright, the first one, 1A. Yes, that matrix is elementary matrix because it perform one arrow. Right? Negative 2R1 plus R2. Changes in R2. Okay, 1B. Matrix B is not an elementary matrix because it performs two elementary row operations, which are number 1, negative 2R1 changes in R1, 2R2 plus R1 changes in R1. Okay, F, matrix F, this is elementary matrix. The arrow is negative 3R2 plus R1 changes in R1. Okay, let's move on. Question 2A. Right, given a matrix E1 that is 2 by 2 matrix. So to find E1 inverse, so E1 is derived by performing arrow negative set 2 R2, set 2 multiplied with R2 changes to R2 on I2. Okay, therefore the inverse arrow is the reciprocal of set 2 is 1 over set 2 multiplied with R2 changes in R2. Then you apply on identity matrix. Okay, this inverse arrow apply on identity matrix to get E1 inverse. Okay. Right, number 2B, E3, elementary matrix 3, E sub 3. Okay. So given that matrix 3 by 3, so E3 is derived by performing this arrow on I3. So from this arrow we can get inverse arrow. Now this negative 2R2, right? So for addition, negative number change to positive. So 2R2 plus R1 changes in R1. Then from this inverse arrow, right? So we can use this inverse arrow on identity matrix 3 by 3 to get E1 inverse. Right, next question, number 3, given AB, matrix 2 by 2. Now 3A to state a sequence of elementary row operations. So to get these elementary row operations, right, that been used to in reducing from matrix A to matrix B, right? Let's do this. So from A to get matrix B by performing these two arrows, right? These two arrows. So first elementary row operation and then second elementary operation. So this is a sequence of elementary row operations that performed to reduce A to B. Right. Question B, find a sequence of elementary matrix. Okay, question A, sequence of arrow. Now sequence of elementary matrices, that means we want to find two elementary matrices because we got here question A, 3A, 2 arrows. So we can get only two elementary matrices. right? Arrow 1 will give E1. Alright, arrow 2 will give E2. So the sequence B equals to E2 multiply E1 and then multiply A. Right, so I hope you understand this. Right, 3C, state the inverse arrow. So we got this arrow from previous question. The arrow is negative to R1 plus R2. So the inverse of first arrow is 2 R1 plus R2 changes in R2. Remember this addition, right? So addition, the multiplication of scalar, right? This is negative number. So for inverse arrow should be positive number. Your second arrow, 1 over 2. 1 over 2 R2. So reciprocal of 1 over 2 is 2, right? Is 2 R2 changes in R2. So from these two inverse arrow, so we can get the E1 inverse and E2 inverse respectively. Right? For the first one, you get E1 inverse. The second inverse arrow, you get E2 inverse. Okay, question number 4, repeat as number 3, but now different matrices. So given the A and B, right? This question 3, the given matrix or the given matrices are square matrix. Okay, square matrix. So for question 4, it is not a square matrix. It's 2 by 3. Matrix 2 by 3, size 2 by 3. Right, question A, this one okay, it's normal process, right, to get elementary row operation that that will be used to reduce matrix A to matrix B. So we have these two arrows, right? R1 plus R2 changes to R2, and this one. Okay, next, this is what 6 R 6 R2, 6 R2. Okay, changes in R2. 1 over 6, sorry, 1 over 6 R2 changes in R2. So to get E1 and E2 using these two elementary row operations, right, to get E1 and E2, right, you apply on identity matrix. So here identity matrix is of size 2 by 2, right? So, right, it is not, you cannot use 3 by 3 because we should follow should follow rows, rows of the given matrix. So the given matrix is the row of given matrix are two rows, right? 2 rows. So we follow this row, right? Row 2, 2 rows. So the identity matrix is 2 by 2, not 3 by 3. I follow the row. So 2 by 2, identity matrix must square. Remember, identity matrix must square. So R1 plus R2 perform the first arrow to get E1, right? And then perform the second arrow on identity matrix of order 2 to get E2. So the sequence of elementary matrix is E2 multiply E1 multiply A, right? So C is to get inverse. E is to get the inverse elementary row operation, right? Then find E1 inverse and then E2 inverse. Okay, so inverse arrow, right? Here arrow 1 is R1 plus R2. So inverse arrow should be negative lah, negative R1 plus R2. Okay, here the second arrow 1 over 6. So for inverse arrow, reciprocal of 1 over 6 is 6. And then after that, we can we are ready to obtain this E1 inverse, performing the arrows, the inverse arrow performing on, you apply on identity matrix to get E1 inverse, and applying second arrow on identity matrix to get E2 inverse, right? Okay, similar to question 5. So now question 5, the given matrix is of size 3 by 2. So to get, first one is to get the arrows, okay, the elementary row operations from A to B. So I hope this one, no problem with you to get that. The elementary row operations here to reduce matrix A to matrix B, we need two elementary row operations. So just note that this as 1 and the second is as 2 elementary row operation. The question B is to get E1, E2 because this from question A, there are two elementary row operations. So question B, only two elementary matrix. That we can get only two elementary matrix. Okay. So perform this elementary row operation, you should apply on identity matrix of 3 by 3. Remember, follow rows. Okay, follow rows. So row is 3. So elementary, the identity matrix is 3 by 3. Right? Apply this arrow, right? The first arrow on the identity matrix to get E1 and apply the second arrow on identity matrix to get E2. So the sequence of elementary matrix is B equals to E sub 2 multiply E sub 1 multiply A. So for inverse arrow, we need inverse, for inverse elementary matrix, right? We need inverse arrow. So here the inverse arrow, the first arrow is negative 5, right? And negative 5 R1 plus R2. So to get its inverse arrow, negative number change to positive number. So 5 R1 plus R2. Then the second arrow is 1 over 2. Therefore, inverse arrow should take the reciprocal of 1 over 2, which is 2R, R3 changes in R3. And then apply this 2 inverse arrow to get the E1 inverse and E2 inverse, right? Respectively. Alright, then we finish exercise 2.5. So next, we continue tutorial chapter 2, elementary matrix. Okay, I hope you should be ready with your answer for this question. Okay, so number 1, find a sequence of elementary matrix a sequence of elementary matrices that can be used to reduce to matrix A to B. Right. So start with A, okay, and then get the elementary row operations, right? Reducing that will used to reduce from A to B. So first arrow is negative 3R1 plus R2. Second, negative 2R2 plus R3. Third is negative 1 over 10 multiply R3 to get B, right? Equals to B. Okay, next one is to get E1, E2, E3. You apply each elementary row operation on identity matrix of order 3, right? Each one. See that here, you apply negative 3R1 plus R2. So the result matrix is E1, right? The second arrow apply on identity matrix. So the result matrix is E2. The third arrow apply on identity matrix. So the result of matrix is E3. So conclusion, B is equals to E3 multiply E2 multiply E1 multiply A. Question 2, given two matrices, okay, so this matrix is 2 by 3, right? To find the elementary matrix, for this sequence, B equals to E2, E1, A, right? So get the elementary row operation first. So from A, to reduce to B. Right, we used first operation is 1 over 2 R2. Second elementary operation is negative 3 R1 plus R2. So we are going to use these two elementary row operations to get E1. So here, the identity matrix is of size 2 by 2. Follow the given matrix rows. The row of the given matrix is 2 rows. It is 2 rows. So the identity matrix also we use 2 by 2. So apply arrow 1 over 2 R1 to get E1. And then apply arrow 2, the second arrow to get E2. Right, to find matrix E1 inverse and E2 inverse. Alright, from the arrow 2A from the previous question 2A, we get this inverse arrow 2R1, right, and 3R1 plus R2. Right, apply these two inverse arrow on identity matrix 2 by 2. So the result matrix, okay, is E1 inverse, okay, and E2 inverse. Question 5, right, given matrix D. So to find D inverse by using elementary matrices. So first of all, you should get, alright, the arrow. So this question indirectly asks you to reduce matrix D to I until you get I. Right? So to reduce that using elementary row operation, so this first arrow, change row, second arrow, row 1 multiply with 1 over 2. Then the third arrow is 2R2 plus R1. So here is Ref. This is Ref. Another word is identity matrix. Alright. So each arrow, apply on identity matrix to get E1, E2, and E3 respectively. Right? So after that, to get D inverse by applying all the E's. Right? E3 multiply E2 multiply E1 to get D inverse. Right? Here is D inverse. The number 8, given two matrices A and B, find E1, E2 such that B equals to E2 multiply E1, A. Right. So now to get the arrow from A, so this this matrix multiply with negative 4R1 because you want to zeroize the second row. Follow this. Okay, follow B. Okay, we want to get that B. Okay, then apply the second arrow, negative 1 over 3 R3. See that the third row of matrix B, the leading the first non-zero entry is 1, right? So to get that 1, so you multiply negative 1 over 3 to row 3. So done. We have here right, equals to B. We reduce A from A to B. So from this elementary row operations, and then to get E1 and E2 by from this identity matrix 3 by 3. Why 3 by 3 not 2 by 2? Because we follow row of the given matrix. This matrix of size 3 by 2, right? Of size 3 by 2. So we follow row 3. So identity is 3 by 3, right? Perform this first arrow to get E1. Right, the identity matrix perform second arrow to get E2. Right, next question B. Determine E1 inverse and E2 inverse. So of course we should get inverse arrow. So from previous question, the arrow is negative from previous question. 8a, the first arrow is negative for R1, right, plus R2 changes in R2. So the second arrow is negative 1 over 3, right, R3 changes in R3. So to get inverse arrow, since this negative 4, we change to positive 4. R1 plus R2 changes in R2. Right. Inverse arrow number 2, this is negative 1 over 3. So check the reciprocal to get negative 3 R3. And get the identity matrix, right, from this identity matrix, and then apply the first inverse arrow to get E1 inverse. And from identity matrix, apply negative 3, the second inverse arrow, negative 3 R3 changes in R3 to get E2 inverse. Question 11, reduce A to RREF. In other words, that to reduce A to identity. So your end result should be identity. Okay. So take this matrix A. This is 3 by 3. Perform the first arrow elementary row operation, 2R1 plus R2. So the second arrow, R2 plus R1 changes in R1, and the third arrow, 1 over 3 R3. So last result matrix is identity matrix. Question B, to find E1, E2, E3. So based on question A, we already got elementary row operations. There are 3 elementary row operations. So meaning you should get E1, E2, and E3. So apply that each elementary row operation on identity matrix to get E1, E2, and E3 respectively. Right, this is E3. Okay. Right, so for that, I hope you understand the working that I've shown you just now. So let's review the slide. Hopefully all of you understand the solution for each question. Okay, so for that I end this video. Assalamualaikum warahmatullahi wabarakatuh.